Hi, Mr. Richards here, and today's lesson is on measures of variability. First off, what are measures of variability? Well, these are used to describe the distribution of data. And when you're asked to use measures of variability, we're going to be looking at the range, the median, something called the first quartile, and the third quartile, and we'll look at those two in order to calculate the interquartile range. Now, let's get started with our examples. Range can be defined as the difference between the greatest and least values of a data set. So when we look to find the range, we'll look for the highest value, which in our example A is 59, and we'll look for our lowest value, which is 33, and we'll subtract. We get 26 hours is our range. And then we would look at just a list of numbers. We look for our smallest, which is 38, and our largest, which is 91. And we can go 91 minus 38, with a little bit of borrowing with our subtraction, is 53, or $53. So the range is you take your largest value of the data set, your smallest number of your data set, and you subtract. Next, we get into quartiles. And what are quartiles? Well, they are values that divide the data into, when you think quarter, there's 4 quarts, or 4 quarters in a dollar. There's 4 quarts in a gallon, 4 quarters in a game. So into 4 equal parts. The interquartile range is the range of the middle half of a set of data. To calculate it, it's the difference between the third quartile and first quartile. And I think the easiest way to define first and third quartiles is by doing so within the context of an example. And so we have defined the measures of variability for the data in this table, and we have the top medal count for the top 8 countries in the 2010 Olympics. And so if I write these in order from least to greatest, we have 11, 14, 15, 16, 23, 26, 30, and 37. Now the first measure of variability that we can calculate is the range. And the range is simply our largest value minus the smallest value. So 37 minus 11 gets us a range of 26. And that's the range. Next, we can calculate our median. Well, here we have 1, 2, 3, 4, 5, 6, 7, 8 data points. So if we take a little shortcut here to find our median, it's going to be the 8 plus 1 divided by 2 term, which is 9 divided by 2, which is the 4.5 term. So the median here is going to be between 16 and 23. Well, if I take 16 plus 23 and I divide that by 2, I get a median of 19 and a half. So our median here is going to be 19.5. Now, in calculating our quartiles, we are going to have a lower half of the data and an upper half of the data. And our first and third quartile are going to be the median of the lower half for the first and the median of the upper half for the third. So if we wanted to define these, the first quartile is the median of the lower half of data, and the third quartile is going to be the median of the upper half of data. So now if I'm looking at this lower half, what is the median here of the lower half? Well, that's going to be between 14 and 15. If I add those up and divide by 2, I get 14 and 5/10, 14 and a half. So that right there is my first quartile. And so I can list my first quartile as 14 and 5/10, or 14 and a half. Next, for the third quartile, if I look at the upper half of the data, where is my median here? It's going to be between the 26 and the 30. If you add 26 plus 30 and divide by 2, you would get 28. So 28 is the third quartile. And so I can write this out here, third quartile is 28. Now the last thing I need to calculate is what's called that interquartile range, and sometimes you see it abbreviated IR. So our interquartile range is the difference between the third and the first quartile. So if I take my third quartile, 28, and subtract the first quartile, 14 and 5/10, or 14 and a half, I get an interquartile range of 13 and 5/10. So I can write my last one here. The interquartile range is equal to 13 and 5/10. So when you're looking for the measures of variability of a set of data, first, order them from least to greatest, find the range, find the median, and then we have two more medians to find: the median of the lower half of the data, the median of the upper half of data, and then lastly, to find the interquartile range, subtract the third quartile and first quartile to get a result. And those are our measures of variability. Now we have outliers, and we want to find outliers. Well, let's define outliers. An outlier is a data value that is much larger or much smaller than the median and we actually have a way to calculate this. It's data that are more than 1.5, 1.5, or 1 5/10 times the value of the interquartile range beyond the quartiles. So we get to find the median, so we can find the first and third quartile, so we can multiply it by 1.5 in order to look and see if we have outliers. So let's practice this now. The cost in dollars of different books are $5, $2.50, $6, $4.50, $3, $8, $3, $14, and $5. Find any outliers in the data set. Well, let's write these in order from least to greatest. We have the $2.50 book, followed by the two $3 books, followed by the $4.50 book, our two $5 books, our $6 book, the $8 book, and the $14 book. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 books. So to find the median, we could always go, all right, it's my 9 plus 1 divided by 2 term, which is going to be my 5th term. So 1, 2, 3, 4, 5. My median is going to be 5. Next, I get to find my quartiles, so I have my lower half of the data. And the median here is going to be between the second and third there, so it's just going to be 3. So that's my first quartile. Then, if I look at my upper half of the data, I find the median of the upper half in between the 6 and the 8 there, which is 7. So that's going to be my third quartile. Then, I need to calculate my interquartile range. Well, that's just the difference between the two quartiles, so that's going to be 7 minus 3, or an interquartile range of 4. Next, I need to multiply that interquartile range of 4 by 1.5, which is 6. And what I'm going to do with that 6 now is I'm going to take the first quartile of 3, I'm going to subtract that 6 and get negative 3. Then I'm going to take the third quartile of 7 and add the 6 to get 13. So as long as my data is in between negative 3 and 13, then I'm okay. If it's not, that's an outlier. So as I look at my data, these are all in between, but this is not. So my outlier here is going to be 14. So again, in summary here, we'll find the median, we'll find our first quartile and our third quartile, calculate the interquartile range, multiply that by 1.5, subtract it from the first quartile, add it to the third quartile to get our new range of where our data should be. If it's not, it's an outlier. In our fourth example, we need to use measures of variability to describe the data. And when you're asked to use measures of variability to describe the data, my hint to you is to find and interpret the range, median, first quartile, third quartile, and interquartile range. Now, let's get these numbers in order from least to greatest to start. Our smallest is 98, then 144, then we have 224, followed by 237, 245, 262, 286, and lastly 301. Now, let's start with the range. And let's remember that the range is our largest number minus our smallest number, so that my range here is 203. Then, let's find the median. Well, I have 8 terms here. 8 plus 1 is 9, divided by 2 is 4.5, so we're going to be in between the 4th and the 5th term. So right here, we should expect our median. And if we were to take 245 plus 237 and divide by 2, we would get 241. So our median is equal to 241. What about our first quartile? Well, if we look at the back side of our data here, or the lower half of our data, it's going to be between 144 and 224 for my first quartile. So if I add 144 to 224 and divide by 2, that is 184. So our first quartile is 184. What about my third quartile? Well, if I look at the upper part of my data, it's going to be between 262 and 286, and if I add those up and divide by 2, I get 274. So our third quartile is 274. So third quartile equals 274. Now, we have our interquartile range. And so for my interquartile range, that's going to be the third quartile, 274, minus my first quartile, 184, and that's going to be 90. So my interquartile range is equal to 90. And those are my measures of variability. Now, we can write a summary here of our findings. And here's what a summary might look like. We could say the spread of the data, and by spread of the data, that is the range. So the spread of the data is 203. And that sentence refers to our range. Then we can write out that the median is 241. Now, let's talk about our quartiles. We can say during 1/4 of the games, $184 or less were sold. When you think about our data, our first quartile contains 1/4 of our data. And so in that first fourth, less than 184 tickets were sold, and that is a true statement from our data. We can also then say that during 1/4 of the games, And now we'll use the third quartile. 274 or more were sold. Again, saying that, all right, for our top 25% of the games, more than 274 tickets were sold. And then lastly, we can refer to our interquartile range and say the number of tickets sold for, now remember the interquartile range contains half of the data, so we can say for half of the games, is between 184 and 274. So it's one thing to be able to calculate our median, our range, our first quartile, third quartile, and our interquartile range. It's another thing to be able to write a little bit about it, and that's what you're asked to do with this example. In our fifth example, we're going to compare and use measures of variability. So the urban land in a certain western and eastern states is listed below as the percent of each state's total land, rounded to the nearest percent. And so our first step here is to compare the western states range and the eastern states range. Well, if we first look at our western states range, the high end of the western state was 5%, the low end was 1%, so 5 minus 1 gets us 4%. And if we move next to the eastern states range, the highest was 27%, the lowest was 6, and 27 minus 6 is 21. So when we compare these, we can say, well, that one was 4%, this one was 21%, and a simple statement would be the percentages of urban land use in the East vary more, meaning there's more variation here. I mean, there's from 27 to 6 versus 5 to 1. There's a lot more variation in the eastern states range than the western states range. Next, do the data for either region contain an outlier? What we're going to do for each state here is look at the first quartile, third quartile, the range. We'll multiply by 1.5, and we'll determine if there are any outliers. So, let's get to it. Let's look for our median. Now, each of the groups of states has 1, 2, 3, 4, 5, 6, 7, 8, 9 states. So if we take 9 plus 1 is 10, divide by 2, that tells me my fifth term is going to be the median for both of these. So 1, 2, 3, 4, 5. Our medians are going to be right here. We don't have that listed, but we might as well say that our median here for the western states was 2, and the eastern states was 10. And now we get into the lower half of the data to look for the first quartile. We can do both states together. As we look in the middle here, our lower or first quartile here is going to be in between 2 and 2, so that's, well, 2 for the western states. And for the eastern states, I would say that's in between 6 and 7, which results in 6 and 5/10 or 6.5. Next, what about my upper half of the datas? Well, here are my upper halves. For the western states, I'm in between 4 and 4, which is 4. And for the eastern states, I'm in between 14 and 15, so once again, 14.5 here. So we can say the third quartile is 4 for the western and 14.5 for the eastern. So when I look now to calculate my interquartile range, 4 minus 2 gets me 2 for the western, and 14.5 minus 6.5 gets us 8 for the eastern states. Well, if I multiply each of those by 1.5, 2 times 1.5 is, well, 3. And 8 times 1.5 is 12. So when I look then for the outliers, remember what we do is to set up our reasonable range for the data. So I take my first quartile, which is 2 for the western, and subtract by that 3. So I get -1. And then I take my third quartile, 4, and add that 3 to get 7. So in theory, my data that's reasonable without outliers should be between -1 and 7. And for the western states, they are all between that, so there are no outliers there. Now, for my eastern states, we take that first quartile, which is 6.5. We subtract by 12 and get -5.5. Then we'll take our third quartile, which is 14.5, and this time we're going to add that 12, and we get 26.5. And so the appropriate acceptable range without outliers here is -5.5 to 26.5. Well, does our data match that? No. We have that 27 there. So as we determine the outliers, we're going to say, well, yes, we have an outlier. It is in the eastern states, and it is the 27. Lastly, how does the outlier affect the measures of center for the eastern states? Well, this 27 was the outlier. And so what we're going to do as our hint, calculate the mean, median, and mode with and without the outlier. Remember, measures of center, mean, median, and mode. Well, let's do this with first. To calculate our mean, we take our 6, 6, 7, 8, 10, 13, 14, 15, and 27 and add them all together and divide by the 9 states that are there. And this result is 11.7 with that 7 repeating. Now we come to our median. Well, with it, we already calculated our median as the 10. As for the mode, the terms that appear the most often, I have a 6 twice, and that's the only repeating, so there's my mode of 6. So now we get to calculate this without the outlier of 27 and see how that affects these measures of center. Well, for our mean again, this time we'll have 6, 6, 7, 8, 10, 13, 14, and 15, no 27 this time. And we're dividing this time by 8 because we only have 8 terms left. This result is 9.875, a lower result. Next we have our median. And if I just look at these terms again, 6, 6, 7, 8, 10, 13, 14, and 15, now I should expect my median, since I only have 8 terms in between the 4th and the 5th term, which is right here. So my median this time would be 9, and also got smaller. Lastly, let's look at our mode. Well, I still only have that 6 twice. That's the only mode, so we can say the 6. Well, to write this now in words as our answer, we can write that the mean and median increase with the outlier. Could you also write that the mean and median decrease without the outlier? Sure, same thing. But either way, with or without the outlier, the mode does not change. That is it on this lesson of measures of variability. Good luck.